So there are a couple of prerequisites that you should write down. By the end of this lesson, we should be able to find the volume of solids with a known cross-section. But before we do that, we have to know some basic areas and volumes in a non-calculus manner. So make sure you have all these prerequisites written down. Most of them you know. The area of equilateral triangle is probably new. There's a way to figure this one out just based on your other formulas, but it's a pain in the butt, so if you just go and memorize it, that's probably easiest. Area of a square we know, side squared. Area of a rectangle, length times width. Area of a semicircle, pi r squared over 2. Be really, really careful. This is going to show up. This distance right here is r, not the entire diameter across the bottom. Area of a right triangle, base times height divided by 2. And area of an equilateral triangle, square root of 3 over 4, side squared. So an equilateral triangle, all of these sides are the same, so any one of them, same as all the others, just square it and you're good to go. So before we do the calculus way of doing things, we need to know how to work with volume in a non-calculus way. So let's do another prerequisite. So whenever we have a prism, let's just say it can be any like weirdo shape that we want. Let's do something like, let's say this. So it's going to be the same shape all the way up to the top. At least insofar as my artistic abilities allow. And what we've got is that the volume of this prism is going to be the area of the base times the height. I'm going to call this height the width because that's going to be consistent for the language that we've been using in the past. So even though you know this as area of base times height, just call it the width. It's the same idea. This is the base, this area right here, whatever the funky shape is. And then the height or the width is this right here. So this is true for everything. Whenever we have a base, whatever that area is, we're going to multiply by the width or height, however we want to think about it. So let's do some problems. We are going to write an expression for the volume of each of the following prisms. First, let's start off with a prism where the base is a square with side T and the width, let's label that Q. So if I'm going to draw that, that just means I have a square and side S there, width or height of Q. So the volume is just the area of the square times the width. Or, since we know the area of a square, oops, I said this side was T, not S. T squared times Q. Pretty straightforward, also really, really critical. So let's do a few more of those. I just want to make sure you're good to go with all of them. I'm also going to draw these in different orientations. You should be able to find these volumes no matter what. So we're going to say the base is a rectangle with one side x, the other, that says other, side of x plus 3, and a width of z. So let's say our base is over here this time. So here's a rectangle. One side's x, one side's x plus 3. And then the width, we'll let that be z. So our volume is just going to be the area of the base times this z, which is the width. Same idea if the base is a semicircle. With a diameter x, and the width is dx. You might get a sense looking at this of where we're going with this. So I'm going to go ahead and I'm going to draw my semicircle. So this diameter here is x, and then I'm going to draw a little prism. This width here is dx. And so if I'm going to find the volume, it's going to be the area of this base. However, we got to watch out because the area of a semicircle says pi r squared over 2, but the radius is this part right here, whereas here x is this entire diameter. So if we want to take that and we want to make it into a radius, the radius part is right here. This is half that distance, x over 2, and that's what we're going to be using in the formula. So the volume is pi r, which is x over 2 squared. Don't forget your other over 2. And this is again the area of the base times the height or width, which we said was dx. Two more with triangles, and then we'll get into our calculus-y end of things. So let's say we've got one where the base is a right triangle with legs of 3y and y plus 1. The width is dy. Well, I'm going to go ahead, let's draw base, that's a right triangle, and then go up. Here's our other base. I'll extend that out there. Okay, so we're saying that the legs are y plus 1 and 3y, and that the width or the height is dy. So that means that the volume is the area of this base, so 3y times y plus 1, and that was divided by 2. Base times height divided by 2 being the area of the triangle, and then times dy, so this was area of base, and then width. Final one is using our new-ish formula. The base is an equilateral triangle. With side S. The width is ds. So just for kicks, I'll draw it over here. So that's my best shot at an equilateral triangle. One side is S, meaning all the sides are S, and then we can go and make that into a prism. And we're told that the width or the height is ds here. So our volume, once again, is the area of the base, which, if we look over here, root 3 over 4, side squared, and then the width was ds.